Before we continue into our diagram language model, first I would like to explain a bit about how does the embeddings do inside of this diagrams language model. As you might know that the diagram language model is actually the very simplest neural network. It takes only the embeddings, the training, and also the valuation set that coming from the cross entropy. But before we heading into diagram language model, first we have to know how does these embeddings work in terms of the slicing of the number of elements from the sentences. Okay, so I already mentioned about the sentences. Here we just straightforward into the factors. Okay, suppose that we are going to embed the numbers of the value with vocabulary size by vocabulary size. Okay, so this is very simplest thing. On the real lives of the large language model, it will take number of embeddings, the huge number here. Okay, so before we are heading into those kind of a huge number, first we are need to understand the basic works of how that the embeddings. Okay, here I have 2 by 3 matrices with each of these number element, and then I put it into the input of the tensors numbers. Okay, then from the tensors numbers we will do the embeddings with this kind of a module, the NN module. Okay, so we are going to have a look what are those numbers looks like here. Okay, I already compiled that program, so here's the result. So we have 2 by 3 matrices here 2 by 3. Okay, and then the output shape will be 2 by 3 by 32. Okay, this 32 is vocabulary size. Okay, this is the input numbers 2 by 3. Okay, and then the sequence batch of 3, sequence length of 3, and then the embedding dimension in 3. Okay, so on the large language model, this is very common that we are saying that B batch S is 2, the length of sequence is D, and then the embedding dimension is C. Okay, so that's the basic namings here of each. So this is the first tokens from the first row by columns on the input tensor. Okay, so from 1 it goes to the embedding and it will plug out into the 32 numbers. Okay, so then here are all the result of stacking them out for each number of element. Okay, so here we have 2 batches. This is 1 and this is 2. Okay, so if we are referring to this we have 2 batches. Okay, then we have 3 columns. Okay, this is 1, 2, 3. Okay, then we have a number of embeddings 32. So 32, well actually this is not fitted on the monitor. If we take them out all, it should get this 32's number. Okay, let me count it for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah, 11, 12, 13, etc. until all this kind of finish is 32 numbers. Okay, so this is the first tokens of 1. Okay, so let's see the token size of that. This is the last number is 0.69. Here, yeah, 0.69. Okay, so means that this number is from this, yeah, to this. This is the first token, and this is the second token, this third token. Okay, okay. So if you look it into further, mean that the shape are now got new views, yeah. Instead of using 2 by 3 by 32, so in this case we have 3 by 32, okay, by 2, okay. So means that 3 by 32 by 2, okay. So means that on the dimension we have t times d by b. Okay, so this is second understanding. Yeah, well, actually this kind of shape on the real lives we are going to have multiple condition. Yes, means that we have to reshaping probably by b by t by c, b by t by c. Okay, means that we have two dimensions matrix, yeah, or two dimension vector instead of 3, because this kind of format we are going to use for the cross entropy from the PyTorch. Later we are, when we are coming into the complete program here, we are going to have cross entropy. Where is the cross entropy? I think the valuation, yeah. Here, yeah. So here are the logits and the targets. Here we should shift, yeah, the views. Okay, from here, yeah. Yeah, well, later I will discuss further about this kind of shape matrices. But for now, this is the basic understanding about how does the embeddings work. Okay. I think that's it, yeah, guys. Well, actually, I'm still preparing it to make it easier for you to absorb, yeah, of those kind of information. Soon, when we understanding about all this kind of bigram language model, then we can do some AI small large language generation text here. Okay, guys, yeah. I'll see you in the next video.